Okay. All right. So let me go and jump in. Actually, can you just see my screen here, the presentation?
Yes, we can.
Okay. Awesome. Okay. Yeah, this has been a great conference so far. The papers and the work presented so far is really exciting. So what a timely thing to talk about, applying some cutting edge techniques to explore just the breadth and the complexity of COVID-19. We're not alone in this, meaning people are doing some fascinating work. So this is an honor to get to be here. So thanks for having me. Um, so I want to just kind of jump in and talk about some this project is largely exploratory at the time, but I've got a ton of extra projects that are associated with it that we'll talk about towards the end of the presentation. But I'm interested in just kind of a general community detection style paper, understanding, how people are Googling stuff related to COVID-19. And importantly, there's no lack of evidence of COVID-19's effect on the global society. I mean, these sorts of pictures and images are kind of becoming commonplace, from social distancing to empty airports and so on and so on. Importantly, not all the effects are necessarily negative. Like, for example, I'm loving time with my family. At the same time, it just the complexity of COVID-19 on modern society is pretty striking. And so really this kind of leads me to my motivating question, which is how do people self-educate in this socially distanced world that's constantly in flux? It's divided politically, and it's indeed a public health crisis. In other words, I'm interested in how far do these effects of COVID-19 extend, especially at this personal level. Namely, how are people processing information as it relates to COVID-19, largely in isolation? So, like a lot of great social network studies have looked at kind of the effects of these sorts of peer-to-peer relationships and networks, and the personal interaction in the workplace and so on are really powerful sources of information transmission and novelty, as we might kind of traditionally think of it. But we kind of get rid of that context, and now we're in this world of isolation. So to address this question, that's why I go to the place where pretty much everybody goes when they're interested in stuff, and that is Google. Importantly, we can develop a pretty powerful understanding of the social effects of COVID-19 if we're looking to sort of people's everyday habits, and that's precisely how people are Googling COVID-related things. And so what's the technical value of this sort of a project? Well, there are several things. So first, it's kind of a creative, sort of different take on social science inquiry. So as a computational social scientist, we're usually interested in kind of understanding how people are interacting with institutions and with each other and so on. But in this world of Googling and kind of mining Googling behavior of individuals in a socially distanced context, we're changing the scene here a little bit. So it gives us some kind of a different view of the world and of people. Also, it's an opportunity to develop an understanding then of how these sorts of indirect networks, I'm calling them, are formed, and thus how they change. And by indirect, I just mean people are grouped together, yes, in a common space, but only on the basis of similarities across their searches. So there's no coordinated network that's formed on the part of the user, such as like an endogenous network of coordinated information sharing or so on. And so with this type of information, we can make inferences about group structure, yes, and about how group structure changes, but we can't necessarily say anything about causation or anything like that. And so that's why it's kind of a good place to start in exploring this sort of a space. But once we then understand the structure, we can understand how it evolves over time, and how communities within communities crop up and so on. And so this is where I'm starting. This is an exploratory project, just mining Googling people to see, one, structure emerges, and two, what are the contours of that structure? Okay. So to thoroughly explore this space, I'm proceeding in three main stages. And so the first is just a general kind of high level descriptive look at the trends. This kind of set the stage. And then I'm going to use a few different fits of some social networks to look at a couple of different scopes of this sort of behavior at the monthly level and then in the aggregate. And then probe that structure a little bit more precisely using some community detection algorithms. Specifically, I'll be applying 3, and this will help us to kind of pull the structure apart just a little bit. Okay. So some particulars before I dive in. The data are Google Trends data, and I access it via the Google Trends API, and I'm scraping all text from Google searches. And this is going to give me a search corpus of all queries that are related to an initial search for coronavirus. Okay, so I'm filtering out the term coronavirus because I'm interested in everything that's kind of surrounding or peripheral to coronavirus to get a little bit of a thicker sense of how people are thinking about coronavirus when they approach Google. Okay. And so, like the others, all the code for the project is developed open source here at this little repo I just created. And I would encourage you to kind of play around with the code and change the scope and so on, and the granularity and so on and so on. So go take a look at that code if you're interested. And so my process for the paper then includes collecting all the Google related queries in America from the first appearance of coronavirus, which was January 16th. That was the first time it was Googled, to very recently, August 11th, in the initial, when I submitted for the conference, it was July 30th, but now I've extended it by just a few days. And then I just clean, pre-process, and stage all the text using traditional techniques. And then I analyze it, which is those previous 3 stages that I mentioned that we'll be covering next. Okay. Okay, so starting first at the high level exploration, we're just starting here to get a sense of the search space. Again, these are all search terms related to this initial search of coronavirus. And just to give you sort of a baseline to understand, this is the relative interest of all coronavirus searches, okay? And relative interest meaning it's just scaled interest in the aggregate by the day of the highest interest. So we just divide all the days by the most frequent day of Googling. And funnily enough, actually, we can see some cosmetic trends that emerge in the networks, which we'll see in just a bit, from spelling mistakes. Nobody actually really, or a lot of people didn't know exactly what it was called or how to spell it. So that's kind of funny, but we'll talk about that in a bit. But importantly, we can see a few things from this. So first, there are no searches prior to December 19th, which makes good sense. This didn't really exist at the time. And also we see, kind of the highest peak in the American context around, late March, maybe early February, which is about the time that the pandemonium and the confusion and the information and the flux in the information environment was kind of at its highest. But then we see a pretty quickly kind of trickling down of Googling habits related to coronavirus after that. And also, just as a quick side note, you might be wondering, why not COVID or COVID-19? Coronavirus has been used much longer, just in reference to the virus, both globally as well as in the US. And just to give you a sense of that, and to kind of cover my bases, there's what the relative interest looks like, just kind of overlaid with searching for coronavirus. And so sure enough, yeah, much greater relative interest in coronavirus. And so that's where we're going to proceed for the rest of the project. So it's all related search terms based on the initial search for coronavirus for the rest of the project. So another helpful way, just to get a sense of a kind of a general descriptive sense, is to look at the geographic spread of relative interest across the country. And so it's just a really quick choropleth. Again, all the code is there in the repo to produce it or change parameters if you're interested in doing so. But I thought this was fascinating because the relative interest, at least scaled across the full time frame for the searches, is at least not where I would expect it to be. So the highest relative interest was not main hotspots that we saw, like New York or parts of Northern California and Seattle or kind of Washington area, but rather it's in Idaho and so on. So anyway, that was kind of fascinating to me, and also perhaps as is kind of unexpected, as kind of building on the last 2 talks, we see pretty low interest relatively in kind of more traditionally Republican voting states like Texas and Louisiana, Nebraska, and Missouri, and so on. So kind of interesting, but again, this gives us a little bit of to jump into the data a little bit more. And so that's where we're going next. And so we're going to start here with social networks. And in this section, I'm interested in exploring, I guess you'd call it just changes in network topology. And the network topology as it relates to related queries based on this constant initial query of coronavirus. And so in a nutshell, as we're working with text data here, the corpus of Google queries, I'm fitting a bunch of simple undirected networks to help us understand essentially term co-occurrence in this corpus. This will then provide a step to explore the latent structure via community detection, which happens next. And just so because I'm not exactly clear who all is in the audience, just to give you a little bit of brief background on social networks, we're operating in this context on something called an adjacency matrix. And this is just a square matrix in which the column and the row names are the nodes or the vertices of the network, which are search terms. And then the elements of the matrix are just a value of 1 equaling whether or not there's a connection between the nodes, and a value of 0 means there is no connection. And so from this matrix, then we could just count up common usage across all related search terms, and this will indicate their level of connection. These networks can then be weighted, as in our case, and weight means the edges are capturing frequencies. And so greater weights mean greater common usage across these given terms. And substantively, what this means is people are Googling stuff in similar ways versus not. In other words, it helps us understand the structure of the search space. And so here's a quick look at the aggregate network. And so I'll let you kind of take a look at that, and I'll explain just a couple more points here. This network also, it's important to note, is undirected. And all that means is that the target and the source, the connection between the two is not meaningful, such that one term doesn't have to precede another term. So we're not modeling like information flow necessarily. We just, the terms are used together. And so this property is also in line with my approach to text mining in this project, which is just assuming a bag of words in the corpus. In other words, I don't care about the ordering of the terms. I just care about whether or not they're appearing together across the documents, which here is Google search queries, okay? Okay, so another thing to kind of dense regions in this network density of terms that are concentrated around a single term, meaning two things. And so one, that big term right there or there's a couple of big terms mean that yes, the word occurred frequently in the corpus, but everything around it, so the density around that term is that the relative, that it's occurring frequently related to and is related to the use of many other terms that are kind of in that same dense space, okay? And again, giving us a window into how people are thinking about COVID and pushing us closer towards that main goal at the outset of understanding the extent of the social effects. And so we can see a couple of kind of interesting high-level trends here. So for example, we see density around kind of the big term cases, which is helpful. Because this makes good sense, and you can see some other terms, symptoms and county is another one. Stimulus check is another kind of fascinating one. But this is also not, terribly helpful if we're interested in understanding network topology, because even though this is a good aggregate picture, it's not terribly useful given that the information environment around COVID is rapidly changing. So if we want to get a sense of the evolution of the network structure, then we should probably take a look at the networks over time. And so we can take a look at this on a month-by-month basis. And again, you can go much more granular with the code. I would encourage you to do so and share your results with me or with the group. It'd be kind of interesting to see. But anyway, so January, just at the outset from January 16 to 31, we can see that a little bit of a community is kind of cropping up here around virus. And so a couple things to note. I don't know if you can see my cursor, but it's around there, the virus term. So there's one spelling error, and then also people separating corona and virus. And so also related is China and the Wuhan province, which is that was kind of highly covered in the media at the outset. People were just interested, where is this quote unquote coming from, and what's going on. And so this is kind of constraining American Google search habits at the earliest days. But then when we go to February, we start to all of a sudden see a lot more stuff that we're a little bit more familiar with. So people are now interested in the symptoms of coronavirus, and there's another misspelling for you, carnivorous. Anyway, kind of fascinating that would occur enough to actually appear in the network. But another is Italy, one of the earlier countries that were hit pretty hard. And also Johns Hopkins, the creators of the so-called data lake, were at the very kind of at the forefront of collecting a ton of good COVID data. And so people were all of a sudden starting to search.
You have
now,
5 minutes left.
Oh, okay. I'll go a little bit faster. So the only other thing I wanted to point out is in the American context, as we might expect, people were interested in when they're getting their money from the government. So we see, kind of a little community starting to crop up here around their stimulus check. Okay, so you can take a look at all these other things. I can post the slides after. If you're interested in taking a look at those. And so now let's just go to take a look at whether or not latent structure actually exists. And so the motivation with community detection is that networks have these sorts of clusters or modules or whatever you want to call them, or communities. And the idea is that some communities are more densely connected compared to others. And so these are sometimes considered communities within communities or subnets or whatever you want to call it. Density in this case suggests that people are Googling similar terms related to coronavirus compared to others and so on. And another key term in this world is modularity. And this is really important because high modularity means dense connections within a community, yes, but it also means greater sparsity between communities. So the sparsity is high, and also the density is high within smaller communities, thus high modularity. This means the space is really well partitioned. And so this is what we would expect, high modularity in some kind of a space if we think that there are real clear there's real clear structure to the space. And so that's what we're kind of on the hunt for. And there are tons of algorithms out there. I'm just using 3 based on mostly their widespread usage in the literature. So I'm using the Girvin-Newman algorithm, sometimes called quote unquote edge betweenness. I can't go into detail here because of time. I'm happy to talk more about it offline. Also using another algorithm called propagating labels. So basically, it's kind of a nearest neighbors approach where we're iteratively updating the label assignment based on a majority of the neighbors in these smaller communities. And then finally, I'm fitting a greedy optimization of modularity, sometimes called the Clausen-Newman-Moore algorithm. And so this is an agglomerative algorithm. It's greedily optimizing modularity. So it's trying to find these dense little subnets, but not searching across every single possible community. So it's fast, but like k-means clustering, it often gets stuck in a local optimum. All right, so that's just a quick look at the algorithms. This is what we find. So the colors, it's colored by just the different labels that were found from the different algorithms. And again, given that I have basically 1 minute left, I'll just say the punchline here is that there really aren't a ton of really clear communities for about half of the space. But for the other half, around things that are a little bit clearer, like things like symptoms or locations of outbreak and so on and so on, we see kind of tighter communities around those sorts of things where again we might expect. So again, I apologize for basically running out of time, but this is essentially the project in a nutshell. And again, like I said, I'm happy to share these slides after. And here is my my contact information if you want to reach out and chat more. So thank you.